Welcome everyone. Today I will discuss basic concept of vectors. This basic concept is included in CBSE syllabus and also in West Bengal Board of Higher Secondary Education. So, look at the syllabus of vectors. So, vectors and scalars, magnitude and direction of a vector, direction cosines and ratios of a vector, types of vectors, equal vector, unit vector, zero vector, parallel and collinear vectors. Position of a point, negative of a vector, components of a vector, addition of a vector, multiplication of a vector by scalar, position vector of a point, dividing a line segment in a given ratio, definition of dot product and vector product, geometrical representation of dot product and vector product, properties and application of dot product and cross product Scalar triple product, this part is excluded from CBSE and also from West Bengal Board. So, in CBSE, in term 2 exam of CBSE, to the reduced syllabus. So, you get 2 questions from vectors, 1 of 2 marks and 1 of 3 marks. So, total 5 marks from vector. And this part is the easiest part. So, this is syllabus. In lower class, from lower class, we are familiar with 2 types of quantities. All of you know it. Quantities like mass, length, time, temperature, density, work done, time period. They have only magnitude. They are represented by their magnitude only. So, you know, the physical quantity which is represented by magnitude only is called a scalar. So, all of you know it. So, quantity, physical quantity. So, scalar. And another one is vector. All of you know it. Now, second type of quantities which is not completely determined by magnitude only. So, for example, displacement, velocity, acceleration, force, weight, momentum, etc. They are not completely determined by magnitude only. They have direction also. For example, you know weight of a body. So look, weight. It always acts downwards. So it has a direction. It has magnitude as well as direction. So, the quantity which has both magnitude and direction, they are called vector quantity. So force. So suppose this is a rigid body and a force acting on it, a force acting on it. So this force has direction. So it is also vector quantity. So quantity which has both magnitude and direction, they are called vectors. So we know this definition from class 6 or 7. So physical quantity, they are of two types, scalar and vector. Now representation of vector. Representation of vector. So look, suppose AB. AB is a line segment. So it has magnitude only. Suppose it is of length of 1 inch. 1 inch or 3 centimeter. So it has magnitude only. So if you give direction, so look, then it will be vector. AB. AB. So you are giving a direction. So representation of vector. Representation of vector. So you know, vector is represented by this is line segment with direction. That is why it is called directed line segment. Directed line segment. Directed line segment with direction. So this is representation of vector. The point A, it is called initial point. Initial. All of you know it. Initial point. And B is called terminal point. Terminal point. So vectors are generally denoted by small letters. You can also use capital letter generally with an arrow overhead. With an arrow overhead. For example, A with arrow, A vector, B vector, C vector. You can also use capital, no harm, this one, capital A, capital B. But we generally use small letter. So previously, it is denoted by bold letter. Now we use small letter with an arrow. So this is representation of vector. Directed line segment. Line segment with direction. Now different kind of vector. What is magnitude? The magnitude of vector. The magnitude of vector AB is denoted by mod AB. This is mod AB. Mod AB. So this is representation of vector. Now different kind of vector. Then in your syllabus, so it is mentioned that different kind of vector. Different kind of vector. Zero vector or null vector, all of you know it. So zero, so AB is a vector. If B coincides with A, then its magnitude is 0. A vector whose magnitude is 0 is called zero vector, and it is denoted by O with overhead 0. It is denoted by O vector, magnitude 0. Next, like vectors. Vectors having same direction is called vectors having same directions are called like vector. Having same direction, so they are like vector. Then unlike, so vectors having opposite direction, we are not considering the magnitude, opposite, so they are unlike. So you do not think that vectors having different direction, they are unlike. Unlike is opposite direction. So like, unlike. Then equal vector. Equal vectors. So look, this is AB and this is CD. Same magnitude and same directions. Same vectors, magnitude and same directions. Then they are called equal vector. So look, equal vectors are like vectors, same magnitude and same direction. Then negative of a vector. So this is OA. So suppose this is a vector. Same magnitude, opposite direction. So negative of a vector A is denoted by minus a vector, and it is a vector of same magnitude but opposite direction. So this is negative vector. Then unit vector. This topic, this is most important, unit vector. A vector A is said to be unit. All of you know it. It's said to be unit if magnitude of A equals to 1. It is denoted by a cap or a hat. It is denoted by a cap or a hat. Now, some more vector, co-initial vector. Co-initial vector. Look, vectors having same initial point. Two or more vectors are said to be co-initial if they have same initial point. So what is the initial point? O. Same initial point. So OA, OB, OC are co-initial vector. Now collinear vectors. Collinear vectors. So two or more vectors are said to be collinear. Are said to be collinear. Collinear if they lie on same line. Same line or parallel to same line. Same line. Today we say two vectors are said if they lie on same line, they are collinear. But now we define it in this way: if they are not collinear, if they do not lie in same line, then they are also collinear. If they lie on same line or parallel to same line. So look, A, this one is B. Look, this is A vector. AB is A vector. CD, this is B vector. They lie on same line. So A and B are collinear. Look, here A and B are not in same line, but parallel to same line. Parallel to same line. In this case also, we say vectors are collinear. Mind it. So collinear vectors, that is why collinear vectors are called parallel vectors. Collinear vectors are called parallel vector. So you should know the definitions. So definitions are not useful for exam. So now coplanar vectors. So coplanar, same type of definition, coplanar. Look, this is a plane. So look, they lie on same plane. So they are coplanar. Then coplanar vectors, exactly same that of collinear. Look, in case of this is in case of line and in case of plane. Two or more vectors are said to be coplanar. 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 If they lie on same plane. Same plane. Or parallel to same plane. Same plane or parallel to same plane. So all vectors lying in the plane, they are coplanar. So we know it. And second one is, suppose this one is a plane. There are some vectors. And if we take another plane, suppose opposite wall of this room, then they are also coplanar. They lie on same plane or parallel to same plane. So, this is definition of coplanar vectors. Now I consider some basic problems, basic ideas using figure to know equal vector, co-initial vector, collinear vector. Look, in figure 1, so look, this is a ABCD. It is a square. It is a square. So, it is a square. So, look, what is B and D? B and D, look, B, this is a vector. Since it is a square, B and D are of same magnitude. Now, look, B and D have same direction. So, B and D are equal vector. Equal vector. What is the relation between B and D? B and D are equal vector. Now, what is the relation between A and D? Look, A, this one is A and this one is D. So, same initial point. They are, look, they have same initial point. D to C, D to A. So, they are called co-initial vector. Co-initial vector. So, application of the above definition. B and D, look, B and D. So, B and D, they are equal. Also, they are collinear. Collinear because they are parallel. A and C are also collinear. In case of collinearity, so look, A and C, they are not equal vector because opposite direction. So A and C, they are also collinear because they are parallel. We do not see the direction. They are collinear. Here you can say A and C are A equals to, you can also say A equals to negative, A equals to minus C vector. Same magnitude, opposite direction. So you can also say this one. Now what is relation between A and C? A and C. So A and C, look, A, this one and this one. Opposite, same but opposite. So you can say this one. So they are negative vector. So they are also collinear as well as A is negative of C or C is negative of A. Next, look, simple application. This is a regular hexagon. A, B, C, D, E, F. This is a regular hexagon. AB equals to P. This is Q. This is R. This is S. This is T. Now AD is joined. So if you draw the figure, a regular figure, then you see this line and this line will be parallel. Now we have to find relation among the vectors. So P and S, this is P and this is S. P and S, this is regular, so they have same direction, same magnitude, so equal vector. This is R, so CD is R and U, they have same magnitude and direction, so they are equal vector. They are equal vectors. Now PUV, P, this is P, this is U and this is V. So they are approaching from, So they are coming from A. So they are called co-initial. S and T from E. So they are co-initial. U and V, so co-initial. They are co-initial vector. Now, what is relation between P and S? P, this one, and this one. P and S. I have already discussed it. They are equal. Or you can say also collinear. Equal vectors or collinear vectors. Now QVT, Q, this is Q, this is V, this is T. Q, V, T. So they are also, look, Q, V, same direction. T is not of same direction, but they are parallel. So they are collinear vectors. Collinear vectors. So, application of the above definitions. Now, basic concept, a displacement. We know displacement is a vector, a displacement of 40 kilometer, 30 degree east of north. So we know this is east, this is west, north, south. A displacement of 40 kilometer, 30 degree east to north, east to north. This is north, east to north, east to north. Suppose this one is 30 kilometer, this is 40 kilometer, and angle to be measured from east to north, east to north. So this is 30 degree. It is measured from east to north. So OA is the displacement. OA is the displacement. So east to north, and this angle is 30 degree. Now look for the second one. For this figure, north, south, east, west. A displacement of 30 kilometers, 60 degree from south to west. From south to west. An angle is 60 degree, this is 45. South to west. So this angle, south to west, this is 60 degree. And OA, this is 30 kilometer. 30 kilometer. So this one. So OA is the displacement vector. Now so third one. This is east, west, north, south. A displacement of 40 kilometer, 30 degree from west to south. This is west, then south. West to south, OA. This is 40 kilometer, 40 kilometer. And it is measured west to south. And this is 30 degree. This is 30 degree. So, representation of displacement vector. So, today, through this video, I have discussed the basic concept of vectors. So, these are basic ideas. Initial problem, equal vector, unlike vector, like vector. From next class, I will start the basic problems of board problems. So, from next class. So, this is only the introduction of vector. So, thank you for today.